Hello, students. Welcome to part two of rigid motions. We're going to be talking about reflections. But first, we need to know what a line of reflection is. Now, I know what you're all thinking.
Devin Senpai, Professor Kun.
What is a line of reflection? And I'll tell you. So, first, we need to know this. This is a rectangle. And this is a line, a reflection. It gets reflected, whatever this is, on ABCD. ABCD is reflected across this to get A prime, B prime, C prime, D prime. Pretend AB is a mirror or a camera phone camera. And so, therefore, it gets reflected and the orientation gets different. ABCD was once clockwise, now it's counterclockwise since it's been reflected across something. Same goes for counterclockwise to clockwise. If it gets reflected, it changes. But now, we need to also figure out why the distance has to be the same. Because if the distance changes, then it's not a mirror. It's not reflecting what it needs to. And also the angle needs to stay the same, or else it would just be a different photo completely. So B, distance is angle, and is the same for B and B prime away from this. Same goes for everything else. And therefore, AB, actually, let me change this to XZ. Line of reflection XZ is a perpendicular bisector. Oh. Now, okay, how does this help me, Professor Kun? That's what you're thinking. And I'll tell you. This is helpful because we can therefore say that ABCD is reflected across segments XZ, or you can say line of reflection XZ to map onto A prime, B prime, C prime, D prime. Because reflections are obviously rigid motions, ABCD is congruent to A prime, B prime, C prime, D prime. And that's how you can do it off the coordinate grid. Now, we're going to be talking about reflections in the coordinate grid. Alright, you can see that's ABCD. Let's say ABCD, whatever, minimal, here. ABCD is here. Now, okay, ABCD has many ways to go. If you want to reflect over x-axis, this x-axis, and the y-axis, then, okay, if you reflect over the x-axis, look what happens. This becomes this. So it will be A prime, B prime, C prime, D prime. Look how the orientation changes. But also, let's say A is -5, -1. This becomes -5, 1. Look how when you do the x-axis, you reflect over the x-axis, the y becomes the negative counterparts. However, for the y-axis is different. Now a would be let's say a prime prime b prime prime c prime prime d prime prime. A is now 5 1. Look how the 1, no, not the 1, the 5, the x part changes to its negative counterpart. Negative negative 5 is positive 5. So we can say, let's say x-axis, x-axis, y-axis. Reflection over these two is equal to negative, no, x stays the same, and then y becomes its counterpart, while this is, the x changes to its counterpart, but y stays the same. See how that works? As the y-axis changes the x, yep. Alright, now students, what do you think this would be? What line of reflection would this be? Take a second to figure it out. If you said, hold on, this line, you'll be correct. Why? Let's see why. Negative h 3 turns into 3 negative 8 for a prime, d prime, c prime, b prime. You can see this line is perpendicular, not that, perpendicular to this, and oh, you can see it now. And that's how you can find that this or this. But now what is the rule for this? Take a second to figure it out. This should be, did you guess it? Y-X. You can see now, y-x, if a is negative 8, 3, and a prime is 3, negative 8. So first that's negative 8, 3, 2, 3, negative 8. Y here turns into the x here, and the x here turns into y here. Okay, students, please figure this out. What would this ABCD translated by, reflected on, to get A prime, B prime, C prime, D prime? Figure it out. Take a second to pause the video. Okay, you should have gotten this. Y equals negative x. Ignore this. Y equals negative x. Okay, let's see how this works out. Let's see. Let's go from A to this. Let's draw a line. We can see that it would make a perpendicular bisector. Right. Now that would be great, because that's what a line of reflection would be. And you can see with B, you want to draw this out. B would be this. Nice. Now let's, okay. What would the equation be? Y equals negative x. Figure it out. Take a second to, you should have gotten negative y, negative x. So let's see how that works. Negative y, negative x, let's take a for example. Negative 8, 3 into, what's a prime? This is negative 3, 8. Negative 3, 8. And we can see that negative 3 is the negative version of y. So that would be negative y. Then 8 is the negative version of negative 8, which is x. So it would be negative x. There you go. There's your equation. Right, not this. That's hey students. Okay. So we're going to be doing some problems now. Um, in the first video, I did not do any problems, but I'm sure translations are easy. I'm sure you can do that. Alright, now let's start with the first question. Reflect A, B, C, D over line x equals negative 2. Right, we want to find the line of reflection first since we're given it. So x equals negative 2. Whenever x is equal to something, then that means like it's gonna be a straight line. X equals 2 right here. Bad example. X equals negative 2 right here. I can see that A is on the thing. So what we know about reflections, if it's on the line, it's going to be the same. So we plot right here. Okay, B is, now we can see that it's 2 distance away and it's a straight line, which therefore means B would, okay, 2 units away, straight line, 2 units away. B would be right here. So this would be A prime, B prime, and C prime. C 4 units away, horizontal line. So C would be over here. C prime. Bam, bam, bam. Now let's see this one. Y equals 2. Whenever y equals a what do you ever call this? This is integers. These are integers. We can say that y equals 2. It's gonna be a horizontal line. Y equals 2. It will be right here. Y equals 2. Okay. I think B is on the line. Yeah, B is on the line. So B would be B would be B would be straight here. It's not change if it's on the line. Right, B prime. Now let's okay. We want to see this. This is one horizontal from the line. So C would be 1, 1, C would be here. C prime, A, 2 away, so A would be right here. Do you understand, students? You better, because I'm a good teacher, obviously. Okay, oh, this one's a tricky one. Y equals x plus 1. Now let's just graph y equals x plus 1. So y equals x plus 1, it means, let's see, it's going to have a, what should we call it? This is a y-intercept. Oh, y-intercept. It's gonna be like this, y-intercept. It goes to the y-intercept. Y equals x. See, y equals x plus 1. Since we know y equals x is y negative yx, we can use coordinates, but I think you can just see this out. This is one horizontal from A, so A would be right here, A prime. And this is, let's see, 4 and 2 away, so it'll be 2, and 4 away, right? I think that's right. B prime. We can fact check this. Let's see. A -2, 1. Shit. -1, 2. Sorry about that. -1, 2. Then this would be 1, 0. 1, 0. Okay, so -1, 2. -1, 2. X to -1. Since it's +1, we add 1 to the y-intercept. Because this is y-intercept, so we add it to y, so it's gonna be 2, 0. Yeah, I don't know what I'm doing. Cross this out. I'm gonna do this. I'm gonna come back to you later. Hold on. Sorry, students. I got my major from I don't know, Sigma University, but uh everyone make me everyone makes mistakes. Okay. Okay, we can fact check this by saying okay, A is -1, 2, while this is A prime is 1, 0. So how do we get 1, 2, 2, 1, 0? Okay, since this is y equals x, we can do yx. So y 2 -1 x yx. Now the y-intercept, my bad, it does not go only for the y part, it goes for both. So you add 1 on each side plus. So this 2 -1, 2. So wait, hold on. -1, 2 and 1, 0. Hello? Wait, hold on. You subtract on the x because it's the y-intercept. You get a... Oh, look at this face. Look, it would be a 0 outcome. -1 plus 1 is 0. So -1 off 2 is 1. And you add 1 to the y, since it's the y-intercept, to get 0. Let me see if that makes sense for the other points. Okay. Okay, so B is -4, 3, -4, 3. And B prime is 4, -1. So -4, 3, 2, 4, -1. Alright, let's do the yx first. So y and x. Alright, now let's see. Oh, wait, this might be a pattern. So we add 3, we add the x to the y, -1. However, we plus 1 to the x because of the y-intercept, or -1. Hold on, let me try this. Let me try this for the other one. This is revolutionary, actually. Revolutionary. Okay, let's go back. -1, 2, and 1, 0. So it'll be 2, -1. add this. So 1 and minus 1. So 1. Okay, so I'm actually onto nothing. Hold on. Oh my, I'm actually onto nothing. Let's see. Alright, let's just prove it by perpendicular bisector. I think that would be nice. Okay, line here. No, let me do black, because black is not saying that. Might get demonetized. I'm trying to get money. Black here. Wait, let's see. So, 8 away, 8 away. Let's see if this works. A is perpendicular, of course. Now B, B is, no, B is not correct. Wait, actually? Wait, I can't tell. Hold on. What's that? Oh, this is making me angry. What the? 8 away. 8 away. Goes here. Oh no. Oh no, it's over here. Wait, is it? Yeah, no. What? No, it's gotta be over here then. Or over here. Oh, B is over here. See, that's the perpendicular bisector. Kids, remember to check your work, because B is supposed to be over here. Oh, well, that's nice. Okay, now let's go. Wait. So what I've been talking about before is actually true. Okay, we find y over x, yx first. Okay, yx first, negative 4, 3, 3, negative 4, negative 1, 2, 2, negative 1. Okay, then, because it's a y-intercept of 1, we do plus 1 to the y, but minus 1 on the x to get 2, negative 3, and 1, 0. Oh my god. I'm gonna experiment more of this later with other y-intercepts. This is revolutionary, actually. Okay, let's see it now. Last problem. I'm proud of you students for sticking by me, for having your trust within me. Okay, y equals negative x. Let's graph this. Y equals negative x. Y negative x right here. Alright. And C. Okay, B using y negative x. Or we can say we can graph it. B over here is C. A is this much away. B line. Okay, and this is this. Yup, this is. Wait, is this B prime? Oh, yeah, B prime, A prime, and let's see, C prime. Fact checked this. Okay, this is -2, 0 for A. Nothing is stopping me from teaching you guys this important information. Okay. So, students, my mic cut out around somewhere here. I'm deeply sorry for this. I was trying to teach you whatever I'm teaching you here. I don't know. I'm kind of on the spectrum, but I bet it was really useful because, like, I graduated from Sigma University and all that good stuff. You're probably like in awe, like,
Oh my god, Professor Devin, you're so cute and handsome.
like I know. Ladies, gentlemen, calm down. Students, calm down. I'm not trying to get Diddy charges, okay? So, yeah, yeah. I'll see you. Yeah. Holy crap, students. I have figured out something. Something so devious. Wait. When you do y is equal to -x minus 2, graph it right now. -2, y equals -x minus 2. You can see that b from -4, 3, we do this, whatever. So -3 and 4. Now we subtract 2. So I guess we always subtract 2 from x. No, we always subtract whatever intercept, no matter if negative or positive, subtracts the positive value of this. So you get -5. But since it's negative now, we do -2 to get -5, 2. -5, 2. Oh my god, -4, -1 as well. Because, oh my god, oh, this is, oh my. No. Let's do another equation. I want to do another one. Let's say, I don't know, y equals -x plus 2 plus 3, -x plus 3. Okay, -x plus 3, -x plus 3, right here. X plus 3. Okay, A is already over here. B. Oh my god. Never mind. I'll just test it with A. -1, 2. Okay, since it's negative, y equals -x, we use this. Okay, -x 1. Okay, since it's plus 3 now, we plus 3, but we still minus 3, right? -5, 4. No. We plus 3 now? Plus 3, plus 3. 4 and 1. 1, 4. Oh, 1, 4. Wait. Oh, so. Oh. Oh, I get it. When it's -x. So wait, when it's -x, both of these will be the same, as in plus 3, plus 3, plus 3. But if it's -3, it'll be -3, -3. Okay, let's try y equals x minus 3. I have not tried that. Y equals x minus 3. Y equals x minus 3. So -3 right here. So A. Okay, sorry, students. Everyone has their mom. So x minus 1. Actually, -2 seems better, right? Minus 2. X minus 2, minus 2, minus 2, right here. X minus 2. Okay, so it'll be, let's see, 3.5. No, 4. So 4 from there, so 4 here. So A prime here. Yep. Okay, so, okay, negative 1, 2. So since it's x is 2 and negative 1. Okay, now let's test it out. So since this is minus 2, we do minus 2, right? And then plus 2. So 4, negative 3. 4, negative 3. Oh my god. Oh, holy. Oh, this is revolutionary. Anyway, students, I hope you enjoyed the valuable lesson and video that I shared today. Make sure to hit that subscribe button, like, and comment down in the video below what you would like me to do next, and I'll see you in the next time. Please don't forget to memorize